Hello student, in the previous lecture we have discussed the working of the nuclear power plant. We have discussed the fusion and fission process. Then we have discussed the basic layout of the nuclear power plant and its working. Now we are going to discuss what are the main components of the nuclear power plants. So the most important component in the nuclear power plant is the reactor. In the reactor we are going to convert the nuclear energy into heat energy. Now, as we are going to use the fission process over there, but if I am not going to control the chain reaction, then that may causes the generation of excessive heat and that will result into the damage. So we are going to use the control rod. Control rods are used in the nuclear reactor to control the fission rate of uranium and plutonium. Their composition includes chemical elements such as boron, cadmium, silver, indium that are capable of absorbing many neutrons. Each reactor designs can use different control rods material based on the energy spectrum of its neutron. Control rods are inserted into the core of the nuclear reactor and adjusted in order to control the rate of the nuclear chain reaction and thereby the thermal power output of the reactor, the rate of steam production and the electrical power output of the power station. So for controlling the power output, we are going to just insert the control rod or you can just pull out the control rod. If you want to increase the power generation, then you are taking the control rod out, and if you want to increase the power reduce the power production, then you are going to put inside the control rod. Now what is a moderator? Moderators are the types of material used in the nuclear reactor that work to slow down the fast neutron produced by the splitting of atom in the fissile compound like uranium-235. To make them more effective in the fission chain reaction, moderator materials include heavy water, light water and graphite. Moderators are normally used to slow down the speed of the neutron. The next thing is shielding. Shielding is very important. An operating reactor is a powerful source of radiation. Since the fission and subsequent radioactive decay produce neutron and gamma rays, both of which are highly penetrating radiation, a reactor must have specifically designed shielding around it to absorb and reflect the radiation in order to protect the technician and other reactor person from the exposure. The shield consists of thick concrete structure around the reactor system referred to as the biological shield. The shield also may contain heavy metals such as lead or steel for more effective absorption of the gamma rays, and heavy aggregate may be used in the concrete itself for the same purpose. Then we are going to use coolant. The main function of the coolant in the reactor is to transfer the heat generated in the reactor to the heat exchanger where the steam is generated. The coolant material should have high specific heat along with high density and low velocity. It should not absorb the neutrons and must have the chemical stability. This is the most important property that you have to just check when you are going to select the coolant. That coolant should not absorb the neutrons. Basically, the commonly used coolants are sodium metal, heavy water, CO2, organic liquid, or can be used as a coolant. So now we are going to discuss the working of the boiling water reactor. There are so many types of reactors, but most commonly used reactors are pressurized water reactor and boiling water reactor. So boiling water reactor is also called as BWR. The boiling water reactors uses enriched uranium oxide as a fuel, has a steel pressure vessel surrounded by a concrete shield. So you can observe over here. So in this is your reactor core. The reactor core has a steel vessel, okay, and it is shielded by the concrete shield. In a direct cycle reactor, it is a direct cycle reactor type. The steam is generated in the reactor itself. So you can observe here, the steam is generated in the reactor core itself. This steam, after passing through the turbine, and condenser. Now after the steam is generated, if you are going to see the working of this one, when the steam is generated, the steam will pass through the turbine where it will rotate the blades of the turbine, and to the turbine shaft we are connected the generator rotates, which will converts the mechanical energy into electrical energy, and that goes to the this one. So when this steam completed its work, that rotation of the turbine, it comes to the condenser where it is going to be condensated. Okay, and after condensing, then again we are going to pump it into the reactor. So this process continues. Okay, for condensation purpose you are going to use the water, which will extract the heat of this steam and just cool it down. So in view of the direct cycle, there is a danger of radioactive contamination of the steam. Ordinary water is used both as a coolant and moderator. So in this reactor, we are going to use the ordinary water, which will serve as a two purpose. It will work as a coolant as well as it will work as a moderator. Such type of reactor is used at Tarapur in India, Tarapur Atomic Power Station. Because of the danger of small amount of fissile material passing through along with the coolant, more biological protection is required. And you need to take one precaution that the operator should not go, or any person should not go 3 meters within a range of 3 meters to the turbine. The advantage of this reactor includes the small size pressure vessel, high steam pressure and simple construction. The overall efficiency of this boiling water reactor is nearly 33%. So this is one of the commonly used reactor. Next reactor is the pressurized water reactor. In pressurized water reactor, the fuel used is the enriched uranium oxide clad in zinc alloy, and pressure vessel is of steel. So you can see over here the fuel which is used over here is enriched zinc oxide, which is clad into the zinc alloy, and pressure vessel which is made up of is the pressure vessel is made up of steel. The pressure vessel and heat exchanger are surrounded by the concrete shield. So pressure vessel and heat exchanger, this one is your heat exchanger and this is the reactor core, pressure vessel. So both are placed inside the concrete shield. The pressure vessel and heat exchangers are surrounded by the concrete shield. Pressurized water is used both as a coolant and moderator. The water is pass into the reactor at 190 degrees centigrade. So when you are going to pass the water into the reactor, the temperature of water is nearly 190 degrees centigrade and 140 kilojoule per square centimeter as a pressure, and is discharged from the reactor at 270 degrees centigrade. This water is passed through the heat exchanger where steam is raised. So this is the heat exchanger. In heat exchanger, when you are going to pass the water through this heat exchanger, the water will extract the heat of this pressurized water, and then the temperature of this will increases to 250 degrees centigrade. This steam is of poor quality. Temperature around 250 degrees centigrade and pressure is 42 kilogram per centimeter square. The steam is condensed in the condenser and condensate returned to the heat exchanger, forming a closed circuit. Okay, so here if you are going to just take an overlook of this one, in the reactor we are going to use the nuclear fuel as a enriched uranium oxide. These are the control rods which will control the amount of chain reaction. So that heat is produced, that heat produces increases the temperature of the water. The water is going to be converted into steam, but this water does not come in direct contact with the turbine. We are using another water. That water will extract the heat in the heat exchanger from this system, and that temperature is nearly 250 to 270 degrees centigrade. That steam goes into the turbine will rotate. When the turbine will rotate, which is connected to the alternator also rotate, which will generate the electricity. After completion of the work in the turbine, the steam comes to the condenser where it is going to be condensed, and again it goes to the heat exchanger. So this process continues. This is the basic working of your pressurized water reactors.